Okay, here we go. So I'm in my book, page 161 actually, and I'm doing problem number 28. Ruth is weighing two job offers. One offers a base salary of $25,000 plus 5% commission, and then the other is $20,000 plus 7% commission. What would Ruth's sales total need to be to make the second job more attractive than the first? Obviously, the first job, she starts off making more money right off the bat, but since the commission is higher, does it make sense to you that if she sells enough, the second one will be the best deal? So your job is to figure out how much she has to sell. So who's got a thought on what an equation might look like for that? What might an equation look like? Jacob?
If you multiply the percentage and the role in the amount, so like 25,000 times 5%, that's 0.05.
No. Let me explain a little bit how commission works. Sometimes if you're in sales, you make a percentage of what you sell, but you also often get a base salary. So she is getting this $25,000 plus 5% of everything she sells. So we're going to let X be her sales. Okay? So if you work straight commission, then that means you don't make any money unless you sell stuff. But a lot of times they give you a smaller salary and then say, okay, now everything you sell you get a piece of. Okay? So her first job offer, this is what's happening. She's getting her $25,000 and then 5% of everything she sells. Okay? Now, what else? Yeah, and I'm not even going to make a separate equation. I want to know where will this be the same as 20,000 plus 0.07x? Because the question is, how much does she have to sell to make this one the better deal? Well, this will tell me how much she sells to make them exactly the same. And then won't anything after that make this a better deal? So we're just going to solve that equation. So 5,000, if I move that over, is 0.02x. So just subtracting 20,000 and subtracting 0.05. So then x is 5,000 divided by 0.02. I should be able to do that in my head, but I really don't trust myself. So I'll type it in on my calculator. 250,000. So I don't know what she's selling, but she has to sell $250,000 worth of it in order to make more money with the second option than the first. Okay, does that make sense to everybody? Anybody have an issue with that? All right, let's look at 31. 31, GTQ, guaranteed test question. This is the mixture problem from first year algebra. You got some of this stuff, you're mixing it with this stuff, and you're ending up with a final solution. Okay? So you might have strategies that you used when you were a freshman, if you can even remember all that back there, and it's fine, I don't care. I'm going to suggest that you just use the general form, amount times percent plus amount times percent equals amount times percent. So again, read the question. You have a couple of different solutions that you're mixing together to come up with a final solution. So if I look at the problem, I have a 10% solution, a 45% solution, and a 25% solution. So I'm mixing 10% and 45%, and I'm gonna end up with 25%. Does that much make sense to everybody? Oh, here, I have something for you. Are you just getting to school?
Huh?
You just getting to school?
I said it. Yeah, I said it.
Oh, okay. Everything okay? So here's your sticker that allows you to be out of uniform.
Thank you.
And there's some things I hand out for another day. I got some stuff I have to hand out. To some of you that were absent the other day. Lori. Hector. Caroline. Ollie. Ollie. This is Caroline. Reed. Okay. All right, so I filled in the percentages. That's easy. It's in the problem. You're mixing a 10 and a 45, and you're going to end up, this is what I end up with. This is what I mix together, end up with a 25. Now, how much of each am I missing? This is where your X is going to come in. Let's read the problem. How much 10%? Isn't that my unknown? I don't know how much 10%. I don't know what that amount is. But I know that I am mixing it with some 45% to make 100 gallons of the final solution. Okay, so I want you just to think about this for a second. You've got some of this and some of this, and it's going to add up to 100, right? So let's think about it like this. Let's just for a minute call it X and Y, and it has to add up to 100. So what does that Y have to be? I really don't want two variables in my problem. What is that Y actually going to have to be? 100 minus X. 100 minus X. Because together they make 100. So Y by itself, that missing one by itself, is going to be 100. You can set up a system of equations if you want, but it's just easier not to. So now I have an equation to solve. So 0.10x plus, okay, I'm going to multiply this out. I'm going to distribute this. So that'll be 45 minus 0.45x. Feel free to use your calculator. Equals 25. And now I'll just solve it. What have I got? Negative 0.35x plus 45 equals 25. If I just combine these like terms. So negative 0.35x equals negative 20. And whatever 20 divided by 0.35 is going to be how much? 20 divided by 57.14. Let's put a label on that. Is it gallons? So I need 57.14 gallons of that 10% solution to mix with this other solution to end up with the final product that I wanted. Jacob?
So, the way the problem is worded, it kind of sounds like it's x.10 plus x.45. So how were you able to figure out it was 100 minus x?
Because the way the problem's worded is, I'm mixing these two together, and I have to add up with 100. So I said x plus y is 100. And then y has to be 100 minus
Well, I
x
guess
then.
I'm confused because it says how much 10% solution and how much 45% solution. So it kind of sounds like x times 10% plus x times.
Well, no, if you're going to use the same variable, then you have to be told you're mixing equal amounts. Does it say you're mixing equal amounts?
Yeah.
No, that's the key right there. If you're going to use x in both spots, then you are mixing equal amounts. And if you were doing that, it wouldn't even be a question because it'd be 50 and 50. Right? So no, that isn't what it means at all. It just means they're unknown. They're both unknown. I don't know how much either one of them is, but I cannot assume that they are equal. Okay? So when it says how much, which almost always these problems do, how much, you're going to put x right there. Caleb, are you ill today? You're ill?
No.
Okay.
I like up.
Huh?
Like you said, thumbs up.
No, I said, are you ill? Because your head's not up, and I need your head to be up, okay? If you need to go see the nurse, I'll send you. Okay, the next question is exactly the same. Let's do this one and see if that straightens out any issues that you might have. Number 32 says, chemistry lab, two acid solutions. One is 20%, one is 35%. We're going to mix them together and get 26% solution. So again, using our general format, which will always work, amount times percent plus amount times percent equals amount times percent. That will always, always work in these solution problems. So, 6 things to fill in. Amount percent for all 3 solutions. The percentages are automatic, they're given in the problem. So we are doing 20% and 35%, and we're going to end up with a 26%. Remember, this one that's over here by itself is your end result. Now, what do we know about the amounts? Well, again, the question says, how much 20% acid? So let's just let that be x. Could I let this one be x? Yeah, doesn't make any difference. I'm just always going to let the first one be x. The only other amount I know is a 25 in the final solution, right? So now I've got to figure out what I'm going to put in here. I can't put x. If I put x here, I can't put x here. Okay? X goes in one or the other, either here or here, but not both. Okay? Now, if you want to use 2 variables and write 2 equations, you can. Or just think about this for a second. If you think of that as y, then together they make 25, right? So what does that mean this one has to be? What is that y value right there? 25 minus x. They have to add up to 25. Don't let that be complicated, kids. That's easy. Think of 2 numbers that add up to 25. Give me 2 numbers that add up to 25. Josh?
5 and 20.
5 and 20. Okay? So 2 numbers that add up to 25. If I put a 5 here, and I know that's 25, what does this one have to be? 20, because that's 25 minus 5. All right, so now I'm ready to solve it. 0.20x plus, use my calculator here to help me with this multiplication, 0.35, I'm going to keep this negative, 0.35 times 25. And 25 times 0.26. So it looks like I have negative 0.15x equal to negative 2.25. Ooh, I got it. 15. Did I do that right? Did you get 15? I need a unit on that. It's liters. On all your word problems, make sure you put a unit on your answer. Amount times percent plus amount times percent equals amount times percent. All right, what's next? We still have some more to do here. 35. In example 3, suppose a parabolic dish has a 32-inch diameter and is 8 inches deep, and the radius of the cardboard cylinder is 8 inches. How tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? I'm going to look at example 3, see what they're talking about there. Oh, they drew the picture for me, so that helps. I just flipped back to the other part of the section, and so my picture looks like this. This is 24, and this is 6. Got this 7 up there. Okay. All right, so in the example, did they change any numbers in this problem, or is that exactly the same? Suppose the pair, oh, it has a 32-inch diameter, so the example is 24, now it's 32 and 8. So they changed those numbers in this example. How tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? Okay, now they suggested, it's always good to read your book, they suggested that you put this thing on a coordinate axis system. It might help you. If we did that, so I'm just redrawing my picture on the coordinate axis system, what information does that give me? What?
What type of BFF it is?
Well, certainly I've got a parabola in there. Does it give me any information about, let's say, maybe those 2 points right there? What does it tell me about those 2 points? Remember, these are the dimensions of the figure. So what do I know about this point right here?
16.
That's 16, comma 8. Would you agree with that? This whole thing is 8 deep. Okay, and then what would this one be?
Negative 16.
Negative 16.8. Okay. Does that help me at all? Could I write the equation of that BFF? Well, certainly, well, we know a third point, right? We know the origin. Certainly, I could use my calculator to do a quadratic regression with the x values, negative 16, 0, and 16, and the y values, 8, 0, and 8. I could do that, but I think I don't need to do that. I think this one's easier. What is the equation of that curve going to look like? Isn't it just going to be y equals something times x squared? Have I moved off the origin? So there's no adds and subtracts, right? But I don't know how fat it is, so that's controlled by a multiplier, right? So let's see, could I figure this out? Let's see, if 8 is n times 16 squared, Does that make sense to you? I'm just using that point. Could I use that one? Yeah, that one wouldn't do me much good, but I could use either one of those. So what does my n end up equaling? I got point, let's make that a fraction. I got 1/32. Does that make sense to you? So now I know the equation of this parabola. What am I looking for? How long the thing is? How long how tall must the cylinder be to fit in the middle of the dish? And I know the radius of the cylinder is 8. So this is the cylinder right here. And I know its radius is 8. No, it's 8 inches deep. And the radius of the cylinder is 8. So this right here, this right here is 8. Does that tell me anything about that point right there? What would I know about that point? I don't know the whole thing, but what do I know about it? I know the x is 4. Now, didn't we already build the equation? So if I put 4 in here, can I figure out that y coordinate? So that's what I'm going to do. Let's see, if I put 4 in there, I get 16, so that's going to be 1/2. Would you agree that's 1/2? Okay, now wait a minute. If that's one, oh, time out. Did it say the radius or the diameter was 8? Oh yeah. How'd you let me get away with that? That isn't 8. This is 8. So this number's 8. The radius of it's 8. This is 8. Not the whole thing. That would be the diameter. That thing sitting in there, that's a cylinder. You can think about that tube sitting in there. So what would that make that? That's a different number. That's 864. 2. If I put 8 in here, now what was the question? How tall is it? So I want that distance right there. Can I figure that out? What would that distance right there be? 6. Yeah. This distance right here from 2 to 8, that distance is 6. Inches, feet, centimeters,
Inches.
what? Inches. So the answer is 6 inches. The other day, I gave you guys a couple of handouts. And at the top of one was written something really, really important for math students to know. Does anybody have those papers handy that I gave you the other day? Not the ones I gave you today, but the ones I gave you the other day. You guys were absent, just got them. So look at the one, oh here, I'm on. There's one that says Precal A 1.7 Notes and Practice at the top. And it says, it's important for students to understand that the solution to a problem is not supposed to spring into their minds fully formed. Successful problem solving takes several tries, including a trip or two down blind alleys. And the reason I'm saying that is because when we're going through something like this that is a little bit different, you can't zone out. You can't zone out and say, oh my gosh, this is so hard, I can't figure it out. You don't get that choice. You have to be able to figure it out. So let's walk back through the steps here. The days are gone, not all the time, but often, the days are gone where every problem you see is going to be exactly like every other problem you've seen, and you just boom, 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 boom. It's not like that anymore. You've got to start putting pieces together and thinking. And in order to do that, you have to be engaged. You can't let me make a mistake like that. Okay? All of us didn't read the problem incorrectly. I read it incorrectly. And most of you weren't reading it. You weren't paying attention. You gotta be on it. So let's go back and review. First of all, we used a hint from the textbook to put this thing on a coordinate axis. So that's a hint now. We're filing away. Sometimes it may help us to draw a picture on an axis system because that provides us with ordered pairs. In this particular case, I use the ordered pairs to do what? Build an equation. And where did that equation come from? My knowledge of my BFFs. And my knowledge of transformations. This had not been moved, so I didn't have to worry about doing a plus or a minus. It hasn't been reflected, so I didn't need to worry about any negatives. But I don't know how fat it is. Stretch and shrink right here, that's your multiplier. Okay? So then, once we got that equation built by just plugging in a point, then we got to looking at it and said, well, wait a minute. I know that half of the coordinate, so let's use our equation to find this half. And once we found that half, then we had our answer, because we just needed the difference in those y coordinates. All right, let's see what's next. That was 35, now we have 37. Water is stored in a conical tank with a faucet at the bottom. The tank has a depth of 24 inches and is filled to the brim. If the faucet is open to allow the water to flow at a rate of 5 cubic inches per second, what will the depth of the water be after 2 minutes? Oh my Lord. All right. What's a conical tank look like? A cone. So here's our cone, right? And the faucet's at the bottom, so this is where the faucet is. It's letting the water out. The tank has depth 24 inches, so this is 24 inches, and a radius of 9 inches, and it's filled to the brim. So it's full. Then we open up the thing, and out comes the water, and it is coming out at a rate of 5 cubic inches per second. So 5 cubic inches per second is how fast it is draining. We're going to leave it open for 2 minutes. Obviously, it's filled up to here now. After we leave it open for a while, then water's going to go down, right? And we want to know the new depth of the water, right? What will the depth of the water be? So I'm going to call that X for now. That's the new depth. All right, who's got an idea? Any idea? Just throw it out there. Something to do. Jacob?
On the graph. Is that true?
Oh, we could. Yeah, we could. This is not like a parabola or something, no. Let's hang on to that idea. If we can't find anything else to do, we'll give that a shot. I didn't think about doing that. Let's hold that. That's a thought. Yeah, Liz?
We could do divide -5 by 100.
Okay, would I divide? I multiply. Because if it's going out, if it's 5 per second, then I would have to multiply by 120 to find out how much has gone out in that time. Yeah, I think that's a great idea. So the water lost or drained off, the water that's gone, will be 5 times 120 or 600 cubic inches. Does that make sense to you? Lori?
We don't want to find the volume of the initial amount.
Okay,
Subtract
so
it.
this, okay, so the volume of the full volume, the original volume, what's the formula for volume of a cone? Your geometry teachers are dying right now. Cones. 1/3 pi r squared h. Does that look familiar? That's cone, 1/3 pi r squared h. So for this original tank, it would be 1/3 pi. The radius was 9, and the height was 24. So I'm going to go ahead and get a decimal for that. So 1/3 pi times 81 times 24. That's a big number. That would be 2,035.75 cubic inches. That was the full volume of the cone. Everybody good with that? Okay, what might we do next?
Subtract 600.
Subtract. So if we take those two numbers and subtract them, so we'll have the new volume. I'll call it the current volume. So the current volume would be that thing that we just got minus 600. Oh, I guess I could have done that. 1435.75 cubic inches. That is my current volume. Okay, so let's come back over here and look at our picture. Here is the new water in the tank. This whole thing is 24. This, I'll call it H, is my new height. And this is my new radius, right? Remember, it's all new now because now the water's down lower on the thing. So the new volume, that number right there, would be 1/3 pi r squared h using the new r and the new h. But we have a problem. Too many variables. So this is what we did last time. When you have too many variables, you have to find another equation that links these two variables so that you can substitute. That's not solvable. I think you understand that equation isn't solvable. You need to have one variable. So let's come back over here. Anybody see a relationship between R and H that we might be able to use? Jacob? What? Oh, yes, that would definitely be true, Jacob. The problem is, I don't know this either. So now I'm going to have a third variable. But yes, that's certainly a right triangle right there, and you could absolutely do a Pythagorean theorem. Speaking of triangles, what's the relationship between the original right triangle and the new right triangle? They are not congruent. What's the word from geometry? Similar. And what do we know about similar figures? Their sides are proportional. So the ratio between 9 and 24, 9 and 24, is going to be the same as the ratio of R to H. Would you agree with that? Which means that 9H equals 24R. And now I need to look and read my problem again. What am I looking for? I want the height. I want the height. So R is 9H over 24. Let's reduce that. 3H over 8. And then guess what I'm going to do with that number, or with that equation? I'm going to plug it in. That's going to go right here. So I have 1/3 pi 3h over 8 squared h equal to 1435.75. That's an ugly looking equation, but you can solve that. Rory?
Where do you get this 3 over 8 again?
You follow this? Cross multiply. Solve for r. So divide by 24. Reduce the fraction.
Bye.
Okay, so I'm going to go ahead and multiply by 3 to get rid of that fraction. So I have 4307.25 equal to, actually it's 26 because I haven't rounded off, so I'll use 26, equals pi times, all right, now what's all this? This is going to be 9h cubed over 64. 9h cubed over 64. Does that make sense to everybody? Square it, you get 9h squared times h is 9h cubed. Square it, get 64. Alright, so now I'm going to solve. This is what I'm solving for. So I think I'll multiply by 64. Again, I'm not rounding off. I'm just taking what's on here. I'll multiply by 64. Then I'll divide by 9. And then I'm going to have to divide by pi. So I have h cubed equal to 9749.63. So I'm solving this equation. I multiplied by 64, divided by 9, and divided by pi. That gives me this number. Now what do I need to do to get my height? Cube root it. Cube root it. You got two choices. When you cube root it, you can raise it to the 1/3 power. That's what I usually do. It's easier for me, but I'm going to tell you how to do it the other way too. If you cube root it, you raise it to the 1/3 power. You can also go to math, your math button, and option 4 for me, but one of the options on there is cube root. So you can cube root, and then that number, I got 21.36 inches. So the height of the water after 2 minutes will be 21.36 inches. Another example of is not plug and chug, folks. You gotta think and be creative. So all those ideas you came up with. The only part I added was the formula, which was important. We need to know that. But the rest of that you came up with. All right, one more minute, all we have. Lord, let's see. 38. Reggie invests $12,000, part at 7%, part at 8.5%. How much is invested in each rate? If Reggie's total annual interest is $900. Believe it or not, this is sort of like a mixture problem in a way. He is investing a total of $12,000 into 2 investments. So, for example, he could put 4,000 in one and 8,000 in one. He could put 6 in each. He could put 9 in one and 3 in one. You got the idea? Now, what is it generally? X and what is this? Please don't say Y. What would this one be? 12,000 minus X. Very, very good. Now, this one is getting what interest? Doesn't matter. One of them is 7% interest. The other one is getting 8.5% interest. You can tell how old this book is. And if I take the total interest, what is that supposed to add up to according to the problem? $900. There's your equation. All right, let's get that last one done. You guys can solve that on your own. 39 says I got a bike, radius 16 inches, tires making 2 rotations per second. Find the bicycle speed in miles per hour. Oh my gosh. Don't we do this in chemistry? What is this called? We used to call it factor label. They have some fancy name for it. I can't remember. Anyway, unit conversion. So we're going 2 revolutions per second. So I'm going to start with that. 2 revs per second. I eventually need to end up with miles per hour. That's what I have to get to. Okay, well, first of all, let's get seconds to hours. So how do we do that? What am I going to multiply by to get my time part taken care of? I know there's 60 seconds in a minute, so 60 seconds, 1 minute. And I set it up like that so those cancel, right? You guys have done this before. I'm not making this up. You've done this before. And not in math maybe, but in chemistry. Okay, and then I know there are 60 minutes in an hour. So now I have, this is what I want to end up with. So now I have my hours. I got that taken care of. Now I have to get miles. And right now all I have is revolutions. So what do I know about this wheel? It has a radius of 16 inches. Okay? Now, when that wheel goes around, a revolution of the wheel is the same as what? Circumference. So every revolution is worth 1 circumference of distance, right? And what's 1 circumference if the radius is 16? 2 pi r. 32 pi inches is 1 revolution. Now, I still am on my way to miles, so what do I know? I know there's 12 inches in a foot, right? So 1 foot is 12 inches. There go my inches. And then, anybody know it? 1 mile is 5,280 feet. There go my feet. And what units am I left with? Exactly what I wanted. Miles on top and hours on the bottom. So then, to get the answer, we just multiply every top number and then multiply every bottom number and divide them. So 2 times 60 times 60 times 32 pi, that's it on top, and then on the bottom is just 12 times 5,280. Did you get 11.42 miles per hour? Okay. All right, let's stop there. It's lunchtime, right? You're like, oh my God, Mrs. Ford, it's lunchtime hours ago. Hayden, 12:35, okay? Hayden, 12:35. Can't hear you. Can't see you. All right, here's the sign out if you need to go get your lunch.
Do you want to stop the video?
Oh yeah, go ahead and stop that. Thank you. Leave it.